and switch it back.
Okay, I started recording.
Start it?
Yes.
Sounds great. Morning. Today is August 12th, Wednesday. This is the Kubernetes Data Protection Working Group bi-weekly meeting. This meeting will be recorded and the YouTube link will be posted later on once published. Today we got a couple of agendas to go through. The first agenda is that last meeting we discussed about the data protection workflows, as well as a detailed kind of breakdown of tasks and assignments into different participants in this working group and run different companies. So we want to follow up on those items. That's one. And the second thing is that Shin and I wanted to give the community an update with regarding to the progress we are making on the container notifier. There were some more discussions between our working group, Signal, Sig Storage, and some other Kubernetes groups with regarding to the design. This time we have focused mostly on security related stuff. And I want to give you guys an update on that. And there are other miscellaneous items over there, I list there. We can go through all these three topics and then we open the discussion to the public. Shin, do you want to, or Tom, do you want to get started on the workflow doc? You guys have put it together?
So yeah, there are like two sections of the stuff that we have started working on. The first one is the section, why do we need data protection in Kubernetes? So Prashanto, are you there? So actually Prashanto has put this together. And then we also had some discussion about the use case section. So maybe Tom, I will ask you to go over that next.
Yeah, sure. If you could open the link that we sent out for that, I think that'd be better. I can also share if it's easier.
And Shen, I'm on the call as well if you need me to kind of go over something.
Okay, so maybe let's go over the first section first. That's the why do we need data protection in Kubernetes? And Tom, then you are next.
Yeah.
Okay, thanks.
Great. So hey guys, this is Prashanto Kochavara from Trilio. So we've been working on a data protection solution for Kubernetes, and we've been kind of orchestrating the reasons and the needs for data protection in general. So I've taken some of that content and massaged it and added it in here. So at a high level, why do we need data protection in Kubernetes? We're breaking this down into three different buckets. So the first bucket talks about cloud native applications, how they have built and how the application DNA or the architecture has changed over with time. We initially had mainframes where the application and the data were kind of together. Then we had the server architecture, client server models, one-to-one mapping between a server and an application almost. Virtualization came in where we were able to do more applications on the same hardware, but the architecture remained fairly constant. Then with cloud native, basically what's happening is all your applications are being broken down into microservices, and each of these microservices have their own identity and their own DNA or own roles and items that need to be protected as a unit. So looking at how the applications have evolved, definitely, it's a new kind of architecture that needs to be adhered to, a new kind of architecture that needs to be supported. And when we look at traditional data protection solutions, we see that the focus of traditional data protection solutions is completely different from how cloud native applications have been developed. They are generally focused on monolithic applications. They are focused on more of the data volumes. some of the items and pieces which we have been taking for granted with legacy solutions, things around networking and security and pieces now are also broken down into additional components. So these traditional data protection solutions are not able to keep up or are not able to match up to how cloud native applications are built, are deployed, and are growing in a way. So that's the first level of discussion point that we've added here. The second point is more around in terms of stateful versus stateless. We've been kind of talking about stateful, stateless around, even with virtual machines and so on. But looking at data, stateful applications are the kind of primary kind of applications that are run within Kubernetes. There are some links that I've added from different analysts. What we are saying here that in order to protect applications successfully, even if obviously if it's a stateful application, you need to protect the container image and the metadata and the persistent volumes. But even if it's a stateless application, there are certain metadata variables and items that may be needed for the application to run successfully in an environment. While we can definitely do that via automation tools like GitOps, Ansible, Terraform to spin that out, spin those stateless applications up again, it will take time. It will take time, and data protection generally is measured in two terms or two variables, RPO and RTO. Protecting the stateless application metadata is going to help reduce that RTO. Not saying that it's completely impossible to recreate that application, a stateless application, without backing it up. You still can, but if we look at it from an RPO perspective, you will still want to capture that metadata because your application DNA is changing, your application is growing, and you would want to capture that to recreate that application in a secondary environment efficiently and successfully. So that's what the second point focuses on. And then the third point is focusing more on the IT roles and personas, right? So one of the things that we all have been kind of using Kubernetes for today is for application, faster application development and faster application delivery. But now this can happen only when, the same kind of tools and technologies can be used across, your IT domain and your developer domain. So you need to have a technology that is centralized, which can be, which can be delegated based on roles and different permissions to operate that same data protection tooling. So the third point basically focuses on the fact that we actually need a cloud native application that can align to the principles of Kubernetes to support data protection as well for both the IT roles.
We lost your voice. Is that just me or?
I can hear him. How about others?
Yeah, I can hear. It's all good.
Okay. I think the screen here just stopped. So.
Oh, okay. So let me try to share.
I can share.
Okay.
Yeah,
so
I thought.
I was thinking the last point. What I was saying is, so basically we need a cloud native solution that can address the needs of both the developers and the IT administrators. So it has to be a unified cloud native data protection solution that gets deployed in a Kubernetes environment.
I got a quick question,
sure,
if I may. Which is very interesting, right? The metadata piece you mentioned, even this applies to even stateless application, which I totally agree. And then you mentioned ITO and RPO. Could you elaborate a little bit why would a cloud native data protection methodology can reduce RTO and RPO compared to GitOps? The end of day is really is just recreate all these resources.
Correct. So you want me to add that into this section?
Yes, it's going to be really helpful if you can clarify that piece.
That makes sense. I'll add it. I'll add that in. I thought I had added it in, but maybe I did not. So I'll add it in again.
Yeah, as a matter of fact, one of the main strong selling points for GitOps is that it is seamlessly not only integrated with your ongoing development, it also is capable of doing automatic rollback, right, based off a certain Git, and also latency-wise is really low.
Correct.
So I'm not sure how to what is our position over here compared to GitOps operation for stateless workload.
I mean, it could be taken in both ways, right? One is, looking at it from a day zero perspective, day one perspective versus, how your application grows, things have changed over time, and you want to recreate that from a point in time perspective. That's one aspect of it. And also when we think about stateless applications generally work within the realm of other stateful applications. So you would have, or not application, but other stateful components. So you could have multiple stateful components talking to stateless components to do its overall application job. So from that angle, I think you kind of look at it from a day zero, day one perspective. Yes, GitOps and everything can help it from that angle. But once your application starts growing, the metadata pieces keep changing. Unless and until you keep track of those metadata pieces, you would want to have a backup available so that you can recreate it swiftly and much more efficiently.
Yeah, I'm not disagreeing. Just don't get me wrong. Yeah, it's better that we have some clarifications over here so that there's no confliction, per se.
Definitely,
And,
yes. Perfect.
Yeah. And another aspect you might also want to think about, talk about a little bit more is the whole effort of XCD backup. Right. Right now, essentially the metadata piece we're talking about Kubernetes resource definitions, right? And there are effort right now in open source, in Kubernetes open source, and actually it is on beta right now, called to protect the XCD, right?
Mm-hmm. Basically
making XCD a duplicated copy from each other, having a redundancy in the XCD level. It is going to be very beneficial if we can distinguish from the data protections work from the whatever is happening in the XCD backup.
Fair, good point. Yeah, I'll add something around that. We've been kind of discussing that internally at Trelio as well, so I can put my thoughts around it, and then we can take a look at it together.
Yeah, thanks. This is very helpful. Thank you.
Perfect. Thank you, guys.
Any more questions? No. The next item is for Tom, right, Xin?
Yeah, so this doc link, we have added this link. Can you go back to the bigger doc just to show everyone how to get to this? Yes, we added doc here in the first section. Why do we need the data protection? So yeah, so please go take a look, and you can add your comments there. I think it's probably the first time most people are reading the docs. So they probably need some time to go through it and see if there's anything that you think should be added. Yeah.
Just to be clear, these docs will eventually come together and build the white paper for this working group. So it's really highly appreciated if anyone can, share your points over there, opinions over there, and it's really also highly appreciated for whoever wrote this doc. It's really nicely wrote, the first finalist. Thanks all.
I had a quick question. Is there a reason why we are using separate docs and not collaborating in the same?
We could. It should eventually come back to the same doc. This is just right now. There are different sections. People are working on them. It's like working in progress.
Okay.
So it's just easier. Yeah. So eventually everything should come together. Of course, we don't want so many different docs.
Yeah.
Yeah.
And would I need different permissions to access that?
No,
Go
I
public.
think this is all. Yeah, this one is already public. I made it. You can add comments there.
Okay. Cool.
Yeah.
Thank you.
Yeah, but if you need any, you need additional permission, you can ping us. Yeah, but I think right now
Sure.
probably you just review it, provide your comments. Yeah, that'll be very helpful. Thank you.
Cool. Thanks.
Okay.
All right.
So-
If no more question, you want to share your screen, Shane, with or Tom?
Yeah, let's make Tom. Oh, sorry.
Please go
Almost,
ahead.
I almost clicked the wrong button. It was a stop recording. Sorry. Let me actually. I think can you stop sharing, and then maybe we'll just make Tom the presenter. Let's see.
I can do that as well.
Okay. Yeah.
It's him here. All right. Actually, I can't.
You
Only
cannot?
you.
Okay, let me find Tom's name. All right. Make co-host. Yeah, it's easier so that they can. Okay,
Yep.
Tom, no, you're the co-host.
Okay, great. Let me. Does that look good?
Yeah.
Okay, cool. So this is much more of a work in progress. I think we got together and put together an outline here. Thanks, Stephen, and yeah. So let's go through this. I think we started more. This is the use case section. So this is kind of the outline for that. We started with kind of the high level of what we need for data protection 4. So that will probably overlap with the previous section. So we should probably maybe merge that a little bit. But we talked about the kind of high-level use cases, and really it comes down to operational recovery and disaster recovery. So they differentiate because operational recovery is what you do through your normal operations. So I can restore something if I'm doing an upgrade of, let's say, like a database version. Maybe I have to back up and restore instances of that database as part of an operational workflow. For disaster recovery, we talked about kind of obviously larger scale outages, and we can talk about kind of the failure domains there as well. I think a second order from there is portability. So doing application migrations between different failure domains as well. So that can be between different clusters, between different namespaces, between maybe different cloud providers, and that also ties into copy data management. So moving data between test instances and production, for example. You don't want to test in prod, but maybe you want to replicate your production setup in your test clusters. We also went into scheduling a little bit. I think this is going to end up being a non-goal. So for scheduling, we talked about having running backup jobs on a schedule. This goes into RPO. And we kind of talked about this is mostly already supported. So for example, Kasten has a scheduling mechanism. Kubernetes itself, you can do things with cron jobs. And I think most data protection vendors kind of have this already built in. And probably the same is true for compliance as well. So you can kind of, you can check to see how compliant you are with the desired schedule. You can check to see if you're compliant with whatever regulations the company is imposing, for example. Yeah. We went into a little bit about granularity. So the granularity of what you protect inside a cloud native environment can change. You might want to do full cluster backups. In many cases, you probably want to limit that to specific namespaces. We did differentiate between namespaces and application a little bit, which we can talk about here as well as individual PVs. And so we talked about that there. We had this open question if apps can span multiple namespaces. I think it's probably okay to take an opinion here. My opinion is that we shouldn't allow this, right? If you're defining, like, for example, a consistency group, maybe that should be limited to a specific namespace. And I think you should be able to certainly back up multiple namespaces on the same schedule. But if it's easier from our implementation side, I think it's probably okay to not consider applications that span multiple namespaces in that sense. We also went through some examples here. to help answer that question. So Stefan came up with a good example where he saw a customer who had a single database that was in use by multiple namespaces, whether that was, you have a single physical database with multiple logical instances. Each instance might be used by namespace, or even one database that had multiple namespaces use different tables within a single instance. There's obviously much more complex applications. SAP is a good example, right? It has a ton of, this one maybe will span multiple namespaces, it has Oracle databases, multiple other components, etc. Right? We also will probably go into depth in some, we'll just mention consistency groups. I think, this is kind of the purview of some other work that Jing is doing, but maybe outside the scope of this working group. But it's worth mentioning, I think, certainly, as a primitive we'll want. I think, was it Sheesh who gave the talk on versioning a few weeks ago? But I think versioning is mentioned, like API resource versioning is mentioning certainly when talking about use cases. I think any kind of migration or upgrade is definitely worth mentioning. So we will include that here as well. We also want to reason about backing up from older versions and restoring into new versions of Kubernetes clusters. And, I think that's certainly a valuable use case. I have a backup from 2 years ago. Over those 2 years, I've upgraded my cluster several times. How am I able to restore that older backup? And we can talk about, direct support from some primitives we have, direct support from vendors, or we can talk about just having, a manual process, right? You have to maybe do the upgrade in steps, where you first upgrade to an intermediate version and then kind of upgrade to the final version. We talked about the different levels of crash consistency as well. I think those are all interesting use cases for data protection. I think we can go through these really quick, but I think what we've seen is that what we've personally seen at Kasten is that there are multiple types of ways that people want to back up their data. And I think in Kubernetes, we kind of want to have the primitives that support them all. So like logical dumps, for example, doing a MySQL dump, Postgres dump, extracting data. This is especially important if you're using something outside the cluster, like RDS, a managed service, where you maybe don't have access to the underlying infrastructure, like the storage or the compute. You just have kind of an API call that you can make. And if you want to back that up, you have to do things at the logical level. What we call it application consistent. So for example, you can find volume snapshots with application level hooks. So you could run the quiesce commands, which I think will be another section, at the application level, at the database level. So like a flush tables with read lock, an fsync lock, MongoDB, that kind of thing. And then use the volume primitives that we have in the community to take volume snapshots there. You could also rely only on volume snapshots, just let the application handle cleaning up. So crash consistent, to just take the volume level snapshots and back those up. And we also talked about dirty reads. So essentially, the worst case, if you have no other option, you can just do a slurp of the file system and grab all the data from there. Of course, you have very low consistency guarantees. But if you're able to orchestrate things maybe at a higher level, if you can say, pause my application while this happens, or if you have like a copy of your application, then maybe that will be okay. Or if the window is small enough, maybe your application can handle a startup just using its normal crash consistent semantics. I think there's quiescing use cases we should talk about here. We probably won't get into detail because there's another section later in the white paper that goes into quiescing in more detail, which I think is still pending. But we'll talk about the use cases for quiescing certainly in this part of the doc. We want to talk about the use cases for backup and data protection in normal operations. So things around how you orchestrate like database upgrades, maybe schema changes, that kind of thing, with data protection primitives. we want to talk about the data protection components. So I think we kind of scoped in application consistency, volume backups, and metadata snapshots. So we kind of talked a little bit about that before. I definitely agree that, one use case is GitOps. So that's a great point, Sean. We should probably mention that here as well and talk about how you can still recover data if you're using GitOps to recover the actual metadata of an application. That's, I think, certainly worth mentioning here. We scoped out cluster infrastructure. So this includes things like nodes, for example, maybe node YAMLs. Typically when we see people handling like disaster recovery, we don't see them restoring like the actual node specs themselves. You kind of rebuild the cluster and then restore the data into it. Even when doing cluster recovery, we don't see that too commonly, but we probably should dig into this a little bit and talk about what parts of that we as a community think are important to support backing up, and which parts we think are kind of handled just by initializing clusters, right? Something that we said was a non-goal was things that are really specific to applications. So if you're like, replication is a good example where I don't think it's within the purview of the data protection group to handle replication directly. I think replication should be handled either by the application, so you can, like MySQL bin logs, for example, or potentially the storage layer. So a lot of SDS systems will replicate their, for example, the blocks directly, or NFS, that you get that kind of built in. For high availability, I think falls into a similar camp, right? This is talking about if, for example, if a single replica goes down, how do you handle that? I think that still falls into the application domain and maybe not the data protection domain. But I think it's worth having that discussion, certainly. When you mention use cases, it's probably important to mention verticals. So we just mentioned big data, maybe ML. There's also kind of brownfield, so taking things that already exist and migrating them into Kubernetes. I think a lot of people are just kind of copying their application stack and putting it in Kubernetes, and then maybe breaking it up into microservices from there. There is something worth talking about with data protection there, where I think anytime you talk about data portability or migrations, it's worth certainly mentioning these type of migrations. What we want to elaborate on certainly is failure domains. I think failure domains are very interesting and important in this space. There's already support in Kubernetes, and I think for at least labeling failure domains, I think like the PVCs, for example, do have some support for this. You can they used to use tags. Now there's explicit annotations. Excuse me. Now there's explicit fields. I think it's worth mentioning here in the context of describing if you have like multi-zone clusters, or if you want to talk about regional disaster recovery. We should talk about that. We should also try to figure out, I think there's another section in this white paper which I think Jing is working on the primitives we need in Kubernetes. And so it's worth kind of, I think, figuring out what failure domain primitives work well, what maybe we're missing there. Something that comes up a lot in data protection is what an application is. And I think that discussion always comes up, right? Sean presented the application CRD, for example, which is a definition of application. One definition of an application could, for example, just be a namespace. Maybe a Helm chart could be a definition of an application. That kind of ties into the granularity, figuring out exactly what the things you want to back up are. I guess my philosophy here is that you kind of try to back up as many things as possible, and then maybe figure out what exactly to restore on restore. But that's definitely a discussion, and I think it's worth elaborating on in the use case part of this, right? Talking about the different types of application definitions we want to support. And I think it's possible to kind of get a flexible definition that supports kind of supports all of these things, right? You know, everything is namespace, for example, even the application CRD. So we can talk about that. I think it's worth elaborating on the specific databases in the use case section as well, talking about the different patterns that exist in databases, how you can perform like application consistent backups of a database, what the logical primitives you need are, what the flow of a backup is. For example, some databases will, when taking a backup, will directly push to an object storage. Some will write to a local file system. Some will kind of stream data out that you can pipe that wherever you want. Talking about that, I think will be in this section as well. I think Stephen brought up this point around self-describing. You know, it's important that these things, when you take a backup of something, you're able to cut references to any local state. This is obviously important for disaster recovery. You want to have a backup be kind of self-contained and self-describing. This I think we repeated. I mentioned RDS and managed services. I think it's worth touching on them, but really for full support for things like VM backups, I think it's kind of out of scope, or maybe future work. We probably don't want to, you know, that gets pretty complex, right? Because there's a lot of different types of external infrastructure. My view here is that we maybe start with logical backups of things like external databases, at least in the scope of this document, and punt on things like backing up, for example, external VMs, backing up, you know, other more complex applications that exist outside of the cluster. So that's kind of the outline. I think there's a lot of details that we have to fill in, certainly, but we have a few people working on this. Is there anything that I missed?
So I think the general comment. So I think my general comment is I feel this is going really beyond the use case section. A lot of this is going to be covered by the following section, which is like what is missing in Kubernetes. So
yeah, definitely.
Yeah, so I think probably we need to sort out a little bit and maybe finish it a few sections first, and those overlapping section, maybe we can do it later. I mean, we of course, when we combine everything together, we can move around things. That's fine. I just right now I just feel this one is covering a lot of things in this use case section.
I think you're right. That's a great point.
Yeah.
So maybe to move forward there, we should start with, well, because this is still just an outline, right? So maybe we can figure out which sections specifically people work on, right? Because I know we have a lot of people kind of working on this in parallel. So we can, and as we pull them out, maybe we'll sync with you, because I know you're working on, you're taking kind of the high level view of the document as well, just to see if we think it should go here or go in it, or if it would fit better in another section, you know, because I know there's, for example, a quiescing section as well. And I think in the use cases you might want to mention it, but we kind of go into detail in the actual section of the document.
Right. Xiangqian.
Yeah, I was just about to say the same thing. Because this area, it's almost the full roadmap.
Yeah, the whole document. This is almost like.
Yeah, but with that said, Tom, I think we have to add another item here, which is encryption.
Yeah, good point.
Yeah, the encryption piece is missing. I think it has to be one of the workflow use cases.
Good point.
Yeah, but in general,
should we add that in the, so the general doc should add that as well, because we don't have that in what is missing. Are you talking about encryption? You want this one to be like a separate, like first class feature, or because right now I think vendor do this already as part of their.
That's not what I was saying. What I was saying is that this working group, how encryption is done is probably out of the scope of this working group. However, whatever the fundamental building blocks we're looking to provide should be capable of taking in any arbitrary encryption mechanism. That's what I was trying to say. And I think this is one of the use cases that the backup needs to have. That's what I was saying.
Definitely, yeah. Are you kind of thinking about ransomware? I mean, there's the use case itself might be, for example, ransomware or just security in general, right? And then maybe the mechanism can be elaborated on in other sections.
It could be in different levels. So like, for example, if you take a REST backup, right, one of the options is that do you want to encrypt it or not?
Yeah.
If you want to
not a use case. So,
come again, please.
Encryption is a requirement, not a use case. Just, I mean,
Oh,
if
yeah.
the use case is I want to transfer data remotely, then encryption becomes a requirement. But, you know, there's not a use case that says encryption, right?
You are right. I probably should make it clear that this is not a in itself alone is not a use case. The consideration has to be there for the use cases. That's what I'm saying.
Okay.
Yeah, requirement is a fair term. All right, thank you, Tom.
Thanks, John.
So Tom, can you share this link with everybody? Add a link of this doc in that use case section, so the others can go and add comments. So are you guys going to fill out the doc and maybe have more contents filled out in the next meeting?
Yes.
Okay, awesome.
Right. There are other topics there.
Can you share your screen?
So I'm hearing weird buzzing sound. Now it's good. Can you guys see my screen?
Yeah.
Good. All right. We talk about this. We talk about this. Yeah.
We should work on this one. Yeah. We should have something already. We just need to put it together. Yeah.
Yeah, we haven't started with this one, and my team member is still on vacation, so
I see.
He's gonna be back.
Okay, I see.
Elliot,
is Elliot here, right? Is it? I thought I see him.
Yeah, I'm here. Yeah.
Okay.
But Oleg is still on vacation, so he's gonna be back next week.
Okay.
He will probably start putting some time together with Elliot to work on this topic.
Okay. I was thinking that Andrew actually shared a doc some time ago talking about this.
Yeah.
Maybe that would be a good starting point, right? With that one.
Yeah.
Okay.
That's what that's what I have asked as well.
Okay.
Prashanto, Dave, any?
I think so. Dave has a conflict that he's not here, but he's very interested in working on this. So yeah, so Prashanto, maybe I can connect you with Dave and can start talking about this section.
Okay. Data populator, same story. Unless Ben, you have something to do. Ben, you have some update?
I don't know if Ben is here. I wonder if he's on vacation. I haven't seen him.
For a little, yes. So, yeah. Anyway, so this will pass. Queries and queries hooks. We will discuss a little bit later with regarding the latest updates. And working volume group snapshot.
Yeah, I haven't put together any doc, but I mean, there is a cap that I'm going to update and set up another meeting to review the cap.
Okay, this one, okay, then the application snapshot backup and restore. This is basically the application definition piece, right?
Yeah.
We probably should also get this kicked off as well.
Yeah. So this one we have something already that you put together some time ago. Yeah, we can. Yeah, we should get this one started too. Yeah, and then I think the
Okay.
last one will be like later. Let's finish the missing pieces and the use case section first before we move on to the last piece. Yeah.
I need to ask everybody a favor over here, whoever has your name over there, please attach your email after your name, so that, for example, if we want to organize some kind of conversation or meetings, that we can reach out to you, or Slack ID, or Slack ID. Can everybody do so, please, if you see your name over there? All right. Then next item, let's move on to the container notifier. Xin, you want to give an overall update on this? We had an hour and a half session again, right?
Yeah, so we had a meeting again with Signode, and this time we also invited Jordan, who is I'm not sure he's part of everything. He's but mainly security side, right? From because he has some concerns over our original CRD approach, so we invited Jordan. So
he's also an API reviewer. Both him and Tim.
Yeah, API, right. Yeah, so I think yeah. So overall, I think the meeting actually went pretty well, right? So at the end, but from Signode side, the thing is, from Signode side, we only have Seth, just have one person. We both SIG chairs from Signode, they have conflict, so they delegate to Seth. Actually, at the end of the meeting, we actually had an agreement that we're going to kind of reduce the scope. Basically, we'll have this during this phase 1, phase 2 approach. In phase 1, we are focusing only on the content notifier action. Probe will be a future phase if needed. And then even for the first phase, we are not going to have a kubelet do retries, because that's a concern, like how long it should retry, what is the kubelet's responsibility if it fails, right? So that cut down some of the responsibility of kubelet, and then it will be the external controller who is making the request for container notifier to do retry if that fails. And then the other piece is the status. I think there are some concerns on the status field. If we are making like a status for each container, then I think there are some concerns. There will be too many updates. So I think the conclusion there is to have like one status per pod, kind of consolidate those, and then but still we will have like an array of status for each container inside that pod. At high level, that's something we're supposed to. Oh, and then there was also there was some ask in the beginning of this document. You can see that Seth added some comments. They want us to write what are the impact on kubelet if we're making this change. So that's something that we need to do. But then I think after the meeting, we got some comments from Derek, who is one of the SIG chair from Signode. He is still concerned. He was asking us to do some prototyping outside of kubelet. So that's you can see the comments here. So here is where we are right now, trying to decide what's the next, what is the next step if we want to do prototyping. Should we do it outside of kubelet? And then, what does that mean? So this is something that we are still discussing.
Yeah, but in general, we kind of made a great progress in last meeting, right?
Yeah.
Couple points I want to, to summarize the couple points. The one is that at least we get agreement from participants of that meeting that we're going to do this in Kubernetes. And the second thing is that we're going to do this in a very restricted way. First of all, we're not going to have Kubernetes doing retry, as Xin was saying. We're going to have limitations on timeout, very strict limitations, right? Kubernetes just basically execute the command, and whatever it's the output is Kubernetes is going to stuck into the status object. It is up to the upper layer controller whoever's used this feature to decide what are the next actions. So you can do retry, you can just give it up, or if it's a signal, etc., etc. And that's that. And the third thing is that we are also looking to limit the number of actions you can define per container. And that way, basically people are having concerns around scalability of Kubernetes. Basically, they are concerned about if some random controller sends out a kubeexec or a notification object to thousands of pods in the system, and there's gonna bring a serious pressure to the kubelet. So those are the basic stuff we are, where the basic feedbacks both Xin and I received from the meeting. Yeah, despite the later piece where she was mentioning Derek has some more comments. But so far, I think from that meeting itself, we made good progress, and hopefully this is gonna be ended soon.
Oh, there is one question, Shantian, that we want to ask this group, which is that requirement. The requirement, like we want to put the limitation on how many actions can be defined for each container. Or is each pod, right?
How many notifiers? Yes, per each code.
Each pod, right? So, would that be a problem if, let's say, if we are doing QoS, let's say if you need to actually run not only application QoS, you also need to go do file fs freeze on all those volumes. Is it okay to put all of those in one big QoS script, just so that we just run it once? I just want to see if this is an issue for any backup vendors here.
So can you play that back one more time?
Sure. Yeah, let me try. So in order to take an application consistent snapshot, you might need to execute a couple steps. For example, the first step is stop from the application container, stop accepting any new writes for SQL database. And the second step is flush my memory into the disk, right? And the third step is maybe potentially FS freeze. And the fourth step is taking a volume snapshot. So those sometimes it can be executed in one command, but sometimes it requires a series of commands and it has to be coordinated. So one concern I think Xin had about limiting the number of notifiers over here is for those who cannot combine those steps together as one single command, as one single action. If we have, let's say, limit the notifiers to number 3, and you need 4 notifiers to do your application level consistent snapshot, then basically this feature is useless to those applications. And what Xin was trying to understand is, are those use cases rare or rather common?
I think in the chat, Ben's got a point that I think in Rubric, and I don't think it's unique to Rubric. You've got multiple injection points.
Can you give more details, like what kind of commands are those?
Yeah.
I need a little bit more context there.
Sure. Hopefully you guys can hear me.
Yes.
It's Ben from Rubric. Yeah. For example, on a VM backup, for more complex applications, we'll run a script before. Basically, we have pre-snapshot, post-snapshot, and post-successful backup. Kind of like 3 injection points we have on a VM. And, for some applications, we'll use, 1 or 2 of those, some all 3. But say like a pre-snapshot would be, hey, get in the application into a quiesce state, flushing everything to disk, etc., and pausing new transactions. And then the snapshot occurs, and then once we've successfully taken the snapshot, we would then go and do the post snapshot, which could be, getting the application back into an operational state. And so they're 2 separate actions that need to be either side of the snapshot, and they're done. The post snapshot, is just done when the snapshot's cleared up. Post successful backup, that's the third injection point that we have, and that's just useful. We have some customers using that just for doing cleanups, log truncation, things like that. Actions that they want to do after they're assured that the backup process itself has been successfully completed. And it's kind of like a third injection point, and they're reasonably common. Not every application, obviously, but a decent number of them, would use at least 2 or 3 of those 3.
So that's actually reasonable. We are actually talking about like everything you do for quiescing, that pre-snapshot, that's combine those into one, and then everything you do after combine into another one. But if you need another one, so let's say if we limit it to 4, would that be enough? 4 injection points, would that be enough?
So from Rubric perspective, yeah, but I'll let others comment as well.
I think it's okay as long as in those injection points, again, thinking of a database, I could issue potentially 3 or 4 steps in the injection point. Right?
Yeah, inside in each one, you should be able to combine them. Actually, that's you can either put them in a script, then you just run that one script, or there's also a way to combine multiple commands, and then that's also possible. Yeah.
Yeah, that should be. Again, I don't want to speak for everyone, but certainly for us, it would be okay.
Okay, and what about Tom or Ashish? You guys have some comments here?
I was trying to think about how, if this makes it less modular, right? If I'm able to define kind of more common injection points, for example, like a volume quiesce, and if I'm forced to do multiple actions within a single notifier, if that would mean that I would need kind of specific notifiers based on the number of volumes, maybe based on specific pod definitions. Whereas if you were able to have more, then you could, for example, have one definition of a quiesce and then reuse that in multiple places.
I think
I think
is that okay? I mean, it's okay, basically, right?
I think it's totally fine to script it. I was just thinking of kind of the modularity of the
because I'm thinking actually you would have to probably need some sequencing. Let's say if you want to do both Quest database and also you need to run FS3, you probably have to info some. You need to do the application Quest first and then do FS3 next. Or there was some sequencing there too, right?
That's right. Yeah.
So probably it's better actually just to put them in one script, and then you can do that in order. Because if you're running them separately, sometimes Kubernetes can't really guarantee the sequencing.
Yeah, definitely. Yeah. No, that makes sense.
All right, we got 1 minute left, right on time. So if you guys are interested or on this, please go ahead and check out this doc. And we have a working group Europe talk. You guys can find the details over here. And Shin and I recorded it. But the time is not friendly at all. It's 5:30 a.m. PST and 8:30 a.m. EST. So if you're interested, please go ahead and listen. Both Shin and I will be online and to answer any questions. Unfortunately, we don't have too much time, but I still want to open issues. Is there anything anyone wants to discuss? At least bring up over here, or shoot me or Shin an email, then we can put your item into the agenda. Any questions? Going once? Going twice? All right, thanks everybody. Have a good day.
Thank you. Bye.
Bye.